For the second part of Notes 49 here, we're going to do problem number 2, which is graphing a quadratic function. And we're going to do all the same stuff that we did in the first problem, starting with, I'm going to find the axis symmetry. So x is equal to the opposite of b over 2a. That is a horrible a. Let's try and write that slightly better there. And so for this one, we've got a b value of 4. So if we do the opposite of that, we would have negative 4 over 2 times. Our a value here is negative 1. So 2 times negative 1. So negative 4 over negative 2. You're going to tell me the x symmetry is positive 2. So that is our axis symmetry. The axis of symmetry gives you half the information you need for the vertex, the x value specifically. The other half of the information for the vertex is going to come by plugging in that x value to the original problem and then simplifying that, right? Evaluating that right side of the problem. So y is equal to negative 2 squared is 4 plus 8 plus 12. Y is equal to, what would that be, 16? Yep, we'll call it 16. So we now have a vertex, we have an axis symmetry. Let's find some x-intercepts. And x-intercepts we're going to find by setting set y equal to 0. Okay, so take the original equation. Y is equal to negative x squared plus 4x plus 12, not 2, 12. Helps if I write all the numbers right in the problem. And I want to solve this for x. Probably the easiest way to solve it is going to be to attempt to factor it. Now, in terms of factoring, the problem that I have with this one, and I can do it, I just don't want to, is right now x squared is negative. I'm not a huge fan of that. So in order to make this easier to factor, I'm going to basically move the right side of this problem over to the left side. That will make this x squared positive. It will make, honestly, the factoring to me just that much faster and easier. So I'm going to add x squared to both sides. I'm going to subtract 4x from both sides, and I'm going to subtract 12, and that will all equal 0. So each of these 3 terms, I moved to the left side, right? All their signs swap, and then this side becomes the 0 that we had originally. Now, factoring-wise, I'm going to split my x, not a split x squared. So split the x up, and then I'm looking to see what multiplies to negative 12 and adds up to negative 4. So negative 6, positive 2. So set your factors equal to 0. And you can tell me x equals positive 6, right? Adding 6, and x equals negative 2. So my zeros, my x-intercepts would be 6, 0, and negative 2, 0. So now I know where I cross the x-axis, which is great. What I need to now figure out, once I've done the zeros, the x-intercepts, is I want to figure out where I cross the y-axis. So I am going to, for the y-intercept, set x equal to 0. So the original problem was y is equal to negative, and I actually have it basically right here. But everywhere I have an x, I'm going to replace it with 0. So negative x squared, so replace the x with 0, plus 4x, replace the x with 0, plus 12. So 0 squared is 0, make it negative. Hey, it's still 0. 4 times 0 is 0, and then, whoops, I said 0, I write 4. Brilliant, I tell you. Actually, human, I tell you. I make mistakes sometimes. All right, but I hopefully fixed that one. So 0 plus 0 plus 12, we're going to have a y-intercept of 0, 12. Sometimes I go too fast. All right, so I've got all the bits, parts, and pieces here. I've got my vertex, my axis symmetry, my zeros, my y-intercept, and I'm going to graph it. All right, so all those pretty little points are going to go on my grid. And so let's kind of do the zoom out here so I can see my grid. All right, so for the vertex, I'm going to start at the origin. I'm going to count 2 to the right because positive 2, and then go all the way up to positive 16. That's going to be a point right there. My zeros are on the x-axis, so positive 6 and negative 2. And then I cross the y-axis at positive 12, so 0, 12. And of course, the axis of symmetry is that dotted line that's going to go through your vertex, which is the line x equals positive 2 here. So we've got all the pieces in the right places. One of the things you might notice if you see this question compared to the last equation, compared to the last graph, this particular graph is going to be concave down. In this case, your vertex is going to be the maximum, the highest your graph ever gets to. How do you know which way is concave up versus concave down? If your x squared term is negative, your graph is going to be concave down. So let me see if I can play connect the dots here and make a halfway decent graph. The halfway decent part is I'm okay with that. So let's see what we got here. Curve, 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 hit the vertex, and then start the curve on down. There's a little wobble, a little shake there. I'm going to call it okay. I'm not going to lose my mind over that. Okay? So I've got the graph. I've got all the bits, parts, and pieces. The last two, I want a domain. Domain in this case would be, again, how far to the left your graph goes, how far to the right does your graph go. So your possible x values here are going to be everything, right? Negative infinity to infinity. So that's your domain. And then range-wise, because this is concave down, if I ask you how low this graph goes, the graph goes to infinity, low. So that would be a negative infinity. And then how high does your graph go? Well, there is an upper bound. There is a ceiling here where your vertex is that your graph does not go any higher than that. And so that y value from your vertex is 16. And so there is your range. And there's all the bits, parts, and pieces. As I said, I'm going to go ahead and make each of these videos, each of these problems their own separate video. This way they don't get to be too terribly long. If you have any questions or concerns, please let me know, and I'll see you in the next one.